All right. I think people are starting to come in. We'll give it a minute or two here as people start to join. If you want to, in the chat, let us know where you're from as you start to join. We'll wait a few minutes before we get going for everybody to get in. As we get going here too, we're going to have a bit of a video going through the entire demo. We'll have questions and answers afterwards. If you notice down at the bottom of the Zoom window next to raise hand, there's a Q&A button. If you can use that to ask questions, that'll help me out instead of trying to keep track of the chat because there's a lot of y'all. So if we could do that, that would be awesome. And then also I can show it on screen to answer it for questions. So that Q&A button again, down at the bottom next to the raise hand button. If you could use that for questions, that'd be awesome. All right. So again, if you have questions during this presentation, use that Q&A button down there at the bottom. We're going to, it's kind of a pre-recorded presentation for the demo piece, but then we'll be back live after that to go through any questions that you all have. So I think with that, we can kick off the video. Hi, I'm Richard, one of the developer advocates at Chainlink Labs. And today we are going to take a look at using Chainlink keepers to automate a smart contract and create a dynamic NFT. Now, before we dive into the actual code and getting our hands a bit dirty, let's talk about what NFTs and dynamic NFTs are. An NFT is a token that represents a thing. This is a bit different than a lot of tokens out there that represent a quantity. So NFTs are non-fungible tokens, and that non-fungible piece is what means that they actually represent a specific item, a specific thing. If you were to think about off-chain real-world examples of NFTs, you might think of a piece of art. And artwork is one of the main use cases currently of NFTs. If we head on over to OpenSea, which is a fairly popular place to look at NFTs, we can see that there are a bunch of different collections here. And if we were to take a look at one like CryptoPunks, we'll see that each individual NFT represents a specific item. You can trade them, but they're different. They're not the same. And these items are static. They're not dynamic. And that's great for this use case, but I think we can do a lot more with NFTs if we actually make them dynamic. What are some things that we could do with them? Well, think about having a card for your favorite sports team and sports player. Imagine if it was a soccer card and it had in there their stats. But unlike most cards, when you get the physical item, right, it's static, it's locked in time, the NFT could change. It could update with the stats of that player as they performed in every game. And you could see how they were doing, how their career was progressing. You could have an NFT to represent voting. You could have consumer rewards. Think about your loyalty cards you have at like your grocery store or whatever. That could have an NFT instead of a barcode tied to you, and you could see all of your transactions, all of your rewards, everything like that. Something that I thought of was if you had an NFT that represented the title to your vehicle, you could then tie every single maintenance item that had been done to that vehicle, the entire history of that car, to that NFT. And it could update over time as things change. You could even think about like a passport. And as you go different places, your passport NFT could update and show all the different countries that you've been to. I think that's awesome. I think there's a ton of potential here. And today we are going to like back way up, not talking about passports, not talking about, cards for players. We are going to look at building a very simplistic NFT and modifying its data on chain. And this NFT is going to use a SVG, which is a way of representing an image in code. And don't freak out. We'll walk through everything. I'll explain it all. And let's take a look at what we're actually going to be building. Now, I mentioned it's going to be simplistic. It's going to be this counting SVG. So the background here is going to be static, but this number in the middle, we will use Chainlink keepers to update that number at a regular interval. Again, this is a very simple example, but it's just kind of dipping your toe in the water to see how you can create an NFT and make it dynamic where it actually changes. So this NFT, if I refresh the metadata here, because OpenSea kind of caches the information just to save themselves some overhead. So we refresh that metadata, and then I'll refresh this page, and we'll see the number changed. Now, hopefully you think that's cool. I think it's really cool because there's a couple things going on behind the scenes here that are pretty neat. First of all, this entire NFT is stored on the blockchain. I'll show you how to do that here in just a minute. We'll walk through the code, and all of the code for this tutorial, for this example, will be available to you so you can copy, paste, and play right along with me. Now, this number changed, and I didn't do this with keepers yet, but we'll get into that in a moment. So how do we create an NFT where all of the information is stored on chain? Well, the first thing we're going to need to do is we're going to need some sort of skeleton for our NFT project. And personally, I like to use OpenZeppelin. OpenZeppelin has a series of contracts that are the industry standard, and they are battle tested, they're audited, you can rely on them. If you head on over to openzeppelin.com, you can go to their contracts. And this will walk you through installing the contracts locally, but we don't need to do that for this example. If we head to their documentation and take a look here at this wizard, this thing is awesome. So we have ERC20, which is a fungible token. That's going to be like a coin. We have ERC721. That's what we're going to be building. This is the standard for NFTs. These are those non-fungible tokens. And you can name it whatever you like here, give it a symbol. And we are going to check a couple of these boxes. And this is where, like, this thing is awesome. I think it's great for starting out. We want to be able to mint our NFTs. We want to increment the ID of our NFTs. And then we want to have URI storage. This is essentially where the metadata, the information of our NFT is going to live. And so we'll have that URI storage. And this here is now going to be the skeleton that we need to start creating our NFT. So you can copy this, or you can open it in Remix. Remix is an online IDE. It's a development tool that you can run in your browser. You can interact with contracts, deploy them. It's awesome. So we're going to start here, and we're going to jump into some code now. And I'm going to use a code editor locally on my machine just to walk through explaining it. But then we'll go back to Remix, and we'll use Remix to actually deploy this contract. So let's head on over to code now. All right, this is the first thing that we're going to look at. And it looks crazy, I know. What this actually is the SVG background that we'll be using for our example. And I want to just take a moment and look at this and talk through it. So we have here that it's an SVG. And then we have this G, that's a grouping. And within that grouping, there's a bunch of circles. And we define the radius of the circle. We define their X and Y locations, and then a fill color. And below we'll have all these different gradients that are essentially defining those gradient fill colors. So what does this look like if we actually take a look at this SVG? It looks like our background, right? So this code on the left is actually what's defining, what's telling the computer to make this nice background. And this is really cool because this is just text. And we can use this text to actually store the information for this SVG on chain. Now, the more complex you get with an SVG, the more intricate the background, the image is, the larger this text file is going to be. And something to keep in mind, when it comes to storing information on chain, the more you store, the more expensive it's going to be as far as gas costs and stuff like that go. So that's something to keep in mind, but we're going to use this SVG to create our background. And then we'll be inserting a text element that has that count in it. So you could have, more complex information, right? We could have a picture with all of the different stats of a player's career, for example. Again, we're keeping this example simple. We're just going to be incrementing a counter. So how do we take this SVG file and store it on the blockchain? Well, this is where things are going to get a little more crazy. We actually are going to encode the SVG via base 64 encoding. And I'll show you how to do this. It's pretty easy to do. This crazy block of code here of text, this is the SVG, like right here, encoded. And what's awesome about this is if you actually head back to the browser and we were to take that and put it right there in our URL bar and press return, it knows how to decode it because it starts out with the fact that it's telling it that it's data and it's JSON, which is the type of information this is, and it's base 64 encoded. So that information is passed into the browser and the browser knows how to decode it. You can see here that this is going to be the name of our NFT as well as the description. And then we have the image, that actual SVG image. And you'll notice again, it's that same thing. It's base 64 encoded here. So if we take this and put it in our URL bar, it'll actually load up. And here you can see this one's already incremented to 1. And that's pretty cool. So that's how we're going to store this picture and all the metadata behind it on the blockchain. We'll be storing it there in a format that looks like this crazy base 64 format. So how do we actually get all of this information onto the blockchain? Well, that's where the contract comes in. So let's walk through this contract. Now, up here at the top, we have our Solidity version, that Pragma Solidity. That's going to tell the compiler what version of Solidity to use. And then we have several import statements. These import statements, they came straight from that skeleton with a few additions, right? We have strings and base 64 as well. Strings is going to allow us to take various data types and convert them to a string, which is essentially just text is how I like to think of strings. And then base 64 will give us that utility that allows us to encode data in base 64 encoding. All right, as we scroll down here, we can see that we have our contract name, count SVG. This is an arbitrary name. Just need to name it something that makes sense to you. And then we're telling it that it's a type of ERC 721. It also is a type of ERC 721 URI storage, and it's ownable. This is essentially telling Solidity that we're going to use those things that we imported just above. We're going to use counters. That's that counter utility that we imported. And we will create a counter called token ID counter. This essentially is going to keep track of our tokens if we create more than one. In this example, there's a few choices I've made to keep things even simpler, where we're going to force it to only deal with the first token that is created, something to keep in mind. Counters often in development environments start at 0, and that's the case here. So just something to keep in mind that a lot of times computers like to start counting at 0. We have our count. That is going to be the value that we are displaying on our SVG, that number in the middle. And that's what we'll be incrementing, increasing with Chainlink keepers in this example. Then we have our constructor. Our constructor is essentially the thing that runs to create the contract on the blockchain. This constructor doesn't really do much. It doesn't have anything in it. Behind the scenes, that ownable contract that we're importing above, that will actually define the person who is deploying this contract as the owner of the contract. And we'll use that later. As you can see just below in the safe mint function, there is the modifier only owner, which means only the person who owns this contract can run that function. Now, we have our safe mint function, right? That's going to actually mint an NFT. It will increment the counter, and then it will mint an NFT to the address that you pass in, and then update the URI for that token. And this is where the magic starts to kind of happen in this example. So we create our NFT, and then we're going to update our URI. What does that mean? The URI, again, is that metadata information that stores things like the name, the description, any other details about your NFT. In this case, the image. So we're going to run a function first within that update URI function called build SVG. That's actually going to create that SVG image. So we have our build SVG function. And it's a lot of code, but don't be scared. It's that same SVG that we looked at just a moment ago. It's just all joined up in one line. And I call that the head of the SVG. We have the head, the body, and the tail. And the one thing that I've done is I've taken off the closing SVG tag and put that in the tail. The reason for that is we need to update the middle of the SVG, the body, with the text that we're changing. Now, within body of SVG, we have a string, and we have this thing, abi.encode packed. What that's doing essentially is that's allowing us to combine multiple strings together. So the first thing we have is we're saying that it's a text element. This is going to let the SVG know that, hey, this is text, it's going to be white. What size font is it going to be? Where is it going to be on the image? The X and Y coordinates. It's going to be right in the middle. Then we have strings.toString. This is, again, that utility that we imported that's allowing us to convert, in this case, the count, which is an integer, to a string so that we can combine it with the other strings of that text element. And then we close our text element off after we've supplied the count. We then have another ABI encode packed, which will combine the head, body, and tail of the SVG. So we get that entire SVG together. And then this function returns that string of final SVG. So we call build SVG. And we store that in a string called final SVG. And then you can see here, there's a lot of this encode packed business going on. But this time, we're going to actually base 64 encode the elements as well. So we base 64.encode, and we need to turn that into a type of bytes. And the bytes will be returned from a string that we will ABI encode packed. This part here, my opinion, is the most complicated part of the whole thing because of the commas and the single and double quotes. You have to make sure that you get all of these little tiny pieces of punctuation correct. Otherwise, things just will not work. So we have here our opening curly brace name. We're calling this counting SVG. You can call it whatever you like. We have a description. What does it do? It's an automated counting SVG. And then we have our image. We pass in the type. It's data. It's an image. It's an SVG that's base 64 encoded. And then we're base 64 encoding that final SVG that we created using the build SVG function. So we base 64 encode the image, and then we kind of wrap that up in another base 64 encoding. Kind of reminds me of like Taco Bell double-decker tacos. If you've ever had those where like you have like the crunchy shell, that's the first base 64 encoding. And then you have like the beans and the soft flour shell. But anyway, now I'm getting hungry. So we double encode our JSON, and then we pass that into the set token URI function. So that'll actually update the metadata for this NFT. And it's going to take a token ID as well. Again, we're going to see where we call this below, and we are always going to run this when we update it with 0, because we only want to update the first token just to keep things easy. So we have our update URI. When we mint our NFT, that's where we call this the first time. Our update URI calls the build SVG function. We talked through both of those. So now the only thing left to talk about is our add count function. And it's pretty simple. Add count. We're going to take our count variable, which starts at 0. We're going to add 1 to it. Then we're going to update the URI of the first NFT. That's it. These two functions below, burn and token URI, those came straight from the wizard. They just need to be there for the Open Zeppelin contracts to be happy. You need to have them in your NFT. So we've got them added here, but I didn't change anything about them. All right, so we've got all this code. We've talked through it. How do we do this thing? How do we actually create an NFT and all that fun, amazing stuff? Well, we're going to need to head to remix.ethereum.org. And you can essentially just, from the code that's shared with this video, paste it in here. And that's all you got to do. This is the exact code that we just walked through. The colors are different. The words are the same. So we've got our imports. We've got our contract. We will need to make sure that everything compiles. You can see here I have a green check mark. And there's that setting, auto compile. I have that checked. That means anytime I make a change over here, if I do something crazy, like this is silly, oh no, that won't compile. And you'll see like, I've got an error now, things are bad. Like, let's not do that. Don't make mistakes. But if you have auto compile turned on, it'll tell you really quickly if you've messed something up. All right, so we've got our code here. We're ready to deploy it. How do we do that? We head on over here to the deploy tab, and there's a few things that you'll need to double check here. First of all, we want to make sure our environment is our injected provider for MetaMask. Now, if you don't have a wallet, you'll need to get one of those. MetaMask is a very common one. I'm using the Brave browser and have the Brave wallet installed. That's kind of outside the scope of this, but if you need help with that, we can definitely supply information on how to do that. The other thing you will need is some testnet ETH. If you head to faucets.chain.link, you can secure some testnet ETH as well. You'll need to connect your wallet. For this example, I'll be using the Go Early test network, but if you need that, you can get that here. Once you have some testnet ETH, you can deploy your contract. You need to make sure these are all the different contracts that we've imported and everything going on here. You need to make sure you pick the correct one. So we're calling this one Count SVG, and then click deploy. You'll be prompted to confirm the transaction. Yours may look slightly different if you're using MetaMask. And then we play the fun game of waiting for our transaction to be successfully executed. You should see down here at the bottom a green check mark show up once things are good. All right, we've got our green check mark. On the left here, you can see we have a deployed contract as well. So if we open up this deployed contract, we have our NFT, but we haven't actually minted one yet. So we'll need to mint one. Up here with your account, you can grab your wallet address and paste it in to SafeMint. We will mint an NFT to ourselves, confirm this transaction, and again, we'll need to wait for this to be completed. At this point, we should be able to see our NFT on OpenSea. We're on the Go Early test network. So OpenSea has OpenSea.com. They also have testnets.opensea.com. So if we head on over to testnets.opensea.com, oops, it is OpenSea.io. Apologies for that. So it's OpenSea.io. If we head on over there and we copy the contract address, it may take a moment. So if you don't see it immediately like this, just go make a coffee or something real quick and come back. So OpenSea does take a moment. Everything with blockchains seems to take a few moments here, a few moments there, as things are confirmed and created and stuff like that. So if we paste it in again, search for it, we may need to wait just a moment. All right, so we refresh our search results. Hey, we see that we have our counting SVG here. And this is the weirdness of OpenSea sometimes. Like, it just takes a moment with OpenSea when you're working super quick like this. So we see our SVG here. You can see the preview, it looks right. When we go and look, we don't see any items, even though it says one item. Again, just be a little patient. Your stuff will show up. It will be there. All right, so we got our item up. It took a couple of minutes. Kind of skipped through that in this video, but we have our SVG now, and you can see it's at 0, right? In our contract, we have a add to count function. So if we interact with that, we could sit here and do this manually and click add to count, and we could wait for it to be confirmed. And once it was confirmed, we could go and take a look at our SVG on OpenSea and see that our count has increased. But I don't know about you. I don't want to sit around waiting to click buttons all day. So how could we do this in an automated fashion, right? We've got our green check mark back from our add count. It's confirmed. If we head back to OpenSea, we'll refresh the metadata, give it just a moment, refresh the page, and you can see our count changed. Cool. Let's automate this now with Chainlink Keepers. So there's a couple ways to do this. I am going to show you the time-based method, which is probably the easier of the two methods. So if we register a new upkeep, we have two options here. We have time-based and custom logic. Custom logic is based on check upkeep and perform upkeep, two functions that we would need to add to our NFT. We're going to stick with time-based, which will be based on the Unix cron tab kind of schedule, and it will let us create a schedule to run a function. So we'll do that, and now we need to provide it with the address of our contract. So we'll copy the address of our contract, paste it in here, and it says, hey, I can't fetch the ABI. That's the thing that lets keepers know what all we can do with this contract. I can't do this. Like, what do you want me to do? I need to know what I can do with your contract. So where do we get the ABI? If we head back to Remix and we head to our compiler tab, right here, we got to make sure that we have the correct contract picked. We've got this awesome little button, ABI. Just click that. It'll copy the ABI and you can paste it in right here. What the ABI is, it's a bunch of JSON information that lets the Keepers network know what they can do with your contract. If you click next, it then will say, hey, we've got all these different functions we can call on your contract. Which one do you want to use on this time-based automation? Remember, the one that we want to use is add to count. So we'll pick that function. We'll click next. And now we can select how often we want something to run. We've got some examples here. We've got kind of an explanation of how cron tab works over here. If you look at some of these examples, you can get some hints on a few things. So the stars mean every. If we divide it by 15, that would mean every minute that's divisible by 15. So every 15 minutes. You can do the same thing with a bunch of different options here. If you wanted the first day of every month, it would be at 0 minutes, 0 hours. So that's midnight on the first day of the month, right? So we have here, we've got our minutes, our hours, our day of the month, what the month is, and then day of the week. Maybe if you want to run every Sunday, every Monday, you can set that up here. If you just Google cron tab, there's an awesome website. I believe it's called Cron Tab Guru. And it kind of breaks things down into human readable formats with the cron tab, so you can make sure that you've got it going the way that you want. Also, you can see here that we give you like the schedule of when it will run, so you can kind of make sure that you're doing what you think you're doing with the cron tab. So let's set this up to run every 1 minute. That's pretty fast. When it comes to running and automating things with keepers, something to keep in mind. It's going to be based on when blocks are mined. That's when the check happens. And so if you try to set it to run faster than it can, like you're going to be limited by your block speed. Depending on what network you're on, 1 minute, absolutely no problem. Some networks, 1 minute might be a problem. So just kind of keep that in mind. This isn't meant to be super, super fast. It's more for automating on a regular cadence. So we'll set that up to run every 1 minute. And then we need to do a few things like provide the upkeep name. So we'll just call this count. And we need a gas limit. So for this example, we're going to start out with, well, let's take a look. How much gas did it cost to actually run the count function? If we open this up and we see here, in here, so it cost a lot of gas. This is what I mean. Like when you go and start updating SVGs and start storing all this information on chain and changing all this stuff, it starts to get expensive, right? So let's copy this gas. Come here and I don't know, I'll go ahead and just make this a bit more just to make sure that we don't run into any problems. Actually, I'll go ahead and just make this the max amount here. In real production terms, you wouldn't want to do that. You'd want to make sure that you are being as accurate as possible, because this will affect how much link you need as well. And remember, if you need link and you don't have it, faucets.chain.link, you can get some testnet link right there. So we've got our link. We've got everything set up. We can give it an email so that it can let us know if anything goes wrong, and register that upkeep. We'll have to approve a couple of things here as it sets things up. It deploys a contract for the cron job, and then we're going to need to fund that upkeep as well. That's transferring the link from our wallet to the upkeep network, to our subscription that we're creating here. So we'll give this just a moment. All right, and then we'll need to approve one more thing. Once this is done, we'll be able to view our upkeep, and that'll give us some more information about it as well. Awesome. Our upkeep has been registered successfully. Let's go ahead and view it. So here there's some information to take a look at. The first thing is the status. We've got our keeper active. We've got our balance of link. We've got our trigger. It's time-based. We see our cron expression. We see when it's going to run next. We've got our gas limits. There's all of our information here. So we are ready to go. We just need to wait about a minute for this to run. All right, so if we refresh the page, we can see here, hey, in our history, we've got a perform upkeep that actually ran. It shows how much it actually cost us. And awesome. This means that we have created a keeper to automate that count function, right? So at this point, if we head back to OpenSea, refresh our metadata, and refresh this page, hey, our SVG is now counting on its own. So again, this is a basic example, right? We're just counting a number automatically, but I think that this kind of demonstrates the framework that you need to create those more interesting, more complex examples that I was talking about at the beginning of this presentation. So this is creating a dynamic SVG that updates itself automatically using Chainlink Keepers. So that automation built into Chainlink Keepers enables you to not sit around and click buttons yourself. You can do time-based or event-based automation. This example, again, we just did the time-based one to kind of keep things a bit simpler. But yeah, with this tutorial, you've created your own NFT, used on-chain SVG storage to create it where it is like 100% on-chain. Like nothing exists outside the blockchain for this NFT. Some projects point to images that are off-chain. This one's all on-chain. I think that's awesome. And it updates itself automatically. Let's see if we've got one more upkeep that happened while I've been rambling on here. We do. And so if we come back and refresh one last time, and then refresh this page, hey, our keeper is still ticking away. And it'll continue to tick away until we run out of link, but we could always top up our link balance if we need to. So yeah, this was creating a dynamic NFT and automating it with Chainlink Keepers. I'm Richard. Let me know what questions you have. And yeah, thanks for watching. All right, so that was past me, not my identical twin. Just to make sure everything worked, and you know, demos are always fraught with danger. But I see there's some questions. We've been answering some of them with text, but there's a couple I wanted to talk about as well. So just kind of digging into these questions real quick. The first one is saying that I've written a smart contract that is compatible with Chainlink Keepers, but I don't know how to trigger a signal on the front end. You're going to need to emit events. It's kind of outside the scope of this, but if you just search for like Solidity events and look at those, you can emit them. And essentially that's like a notification being put out there in the blockchain space, like, hey, this thing happened. And from your front end, you can listen for events as well from a specific contract address. So that's what's going to get you where you can kind of see when something happens in your smart contract. So hopefully that helps out and gets you going in the right direction there. My Twitter is rgottleber. It's my last name, Gottleber. If you want to hit me up on there with that question too, I can give you more information. There was a question about more use cases for dynamic NFTs. And if you have questions, y'all, if you want to use that Q&A button, way I can kind of keep it all in one place, not necessarily the chat. I see some questions popping up in the chat, but if you could put them into the Q&A, that'd help me out a lot. Use cases for dynamic NFTs. We talked about that at the beginning a little bit. The sky's the limit, right? Like you could have like the title of your car, passports, reward cards. I mean, you could create an NFT that just displays the weather using Chainlink data feeds. You could bring in like weather data online and yeah, go from there. Like the sky's the limit. I don't know, like there's so many possibilities. That's why personally, I really love the idea of dynamic NFTs. I think that the current state of NFTs, where they're a way to show ownership of things like artwork, is really cool for that use case, but there's so much more that can be done. We have another question about the SVG scaling with gas efficiency compared to IPFS. So IPFS, it's the interplanetary file system. It is a distributed way to store information online, decentralized fashion, and it creates a hash that will always point to the same bit of data. It's great for NFT projects. A lot of them use it. Absolutely, using IPFS would be more efficient gas-wise. I like using the SVGs just because then everything can be self-contained in the contract, and like it doesn't add that extra piece of like, okay, so now we need an IPFS gateway to get this picture stored somewhere else. But to answer that question, yes, probably a lot more gas efficient. There's a question about, can we use Chainlink keepers on a test network? Absolutely. If you go to faucets.chain.link, you will be able to get both testnet like ETH and Link tokens. And then you can go to keepers.chain.link if you have your wallet set to a test network that we support, like Go Early. That will work as well. So yes, you absolutely can use them on a test network. Speaking of the Link token, there's a question that says, can you explain again the function of Link token and what happens essentially with the balance? So the Link token is a way to basically provide a economic incentive to the different nodes within the Oracle network. So Chainlink is built up of a distributed Oracle network, a DON. And so it's a bunch of different independent people who have Chainlink nodes set up, and they all kind of work together. And the Link token is basically the incentive from an economic standpoint for them to do work. It also allows us to have, we could be on Go Early, which has ETH. We could also be, it's an Ethereum network. We could also be over on a Polygon network, right? And we don't have to worry about the native token. We have our own token for the Chainlink node network. So hopefully that answers that question. Man, y'all are asking a lot of questions. Whew. There's a question about generative art, and apologies if I don't know a lot about that, but I believe that most of the generative art NFTs, they run outside of the blockchain and store an image like on IPFS. So I'm not sure if keepers could do that as well. If you do run out of Link in your keeper funding, yes, it just pauses basically until you add more Link there as well. Just looking through these questions. Other examples of actual artwork changes and stuff like that. Yes, you absolutely can change the artwork too. You could have changed the background color. You could have changed any piece of the artwork as well. There's a question about Link again and the cost. And yes, every time an upkeep runs, yes, it will incur like a small link fee there. You could see that in the example in the history, like each of the 3 different times it ran, or 2 different times it ran, you could see there the fee that was paid. How can NFTs be linked to off-chain events? This is a great question. So using oracles. So oracles are, Chainlink is an oracle network. Oracles bring off-chain data on-chain. So that is like one of the big things they do. Price feeds is probably the most common example that you will have heard of from the Chainlink products, bringing those off-chain prices on-chain into the smart contracts. So you would need an oracle pointing to whatever source of data that you're wanting to reference in your NFT. But yes, you definitely can do that. There's some other demos. If you go to the Chainlink YouTube, there's some other demos there about making dynamic NFTs, and I believe some of them use off-chain events as well. Let's see here. There's a question about how much Link is paid for each function call. That's going to be an "it depends" answer, because Link is essentially used to incentivize the Oracle network to do work. And so it depends, because it's going to be partially dependent on gas fees, as well as what network you're on. In our documentation, there are some documents explaining how to calculate, how those fees are calculated. Yes, somebody's pointing out, yes, it probably does make more sense to store the constant as a constant when the SVG. So it's good for pointing that out. You're absolutely correct. There's a question about who pays for the gas fees during the update. So this is where, again, that link token comes in, right? So when the Keeper network calls the function that is actually updating the SVG, that Keeper node would be essentially paying the gas fee for us, but we are reimbursing them with the link token. Let's see here, just looking through questions, seeing ones that I haven't hit on yet. There is a question, this is an interesting question. So talking about using WebGL to make more complex dynamic NFTs. If I'm understanding your question, I think that it's, when it comes to blockchain data like this and NFTs, another approach to this, instead of having the SVG itself stored on chain, you could have some of the information that you wanted to display in the SVG stored on chain, and then you could do more with it outside of that, right? Like an idea is, instead of having like the random values, if you were using random values to create some piece of artwork, instead of having that actually create the SVG on chain, you could just store those values and then have a programmatic way to interact with those random values and use that to generate your artwork for your NFT. I think that's hopefully answering your question. But yes, you could definitely use a combination of off-chain and on-chain tools as well. Implementing the dynamic SVG. There's a question here that says, I know this implies not using Chainlink for updates, but can the dynamic SVG be implemented on a view function to avoid gas costs? And maybe I'm misunderstanding what you're asking, but I think if you're you can't update the SVG without incurring some form of cost, because anytime you're making a state change to the blockchain, that's going to incur a cost. Asking about the gas cost of this NFT. Again, that's it depends question, depending on when and what chain. But yes, you are correct. Like SVGs, when you store everything on a blockchain like this, it can get expensive. depending on the chain and current gas, like how much it's cost to do a transaction, it could be prohibitive. Absolutely. Looking through here. I think that's most of the questions. So let's see here. Does keepers call the method from within another smart contract or from a server? What if the method has an only owner or approved by owner modifier? So the keepers contract, so the keepers will be using a smart contract to make the call. And if they don't have permission to make that call, like its only owner, then yes, that would fail. So you need to make sure that it's something that could be callable outside. Often people ask this question of like, how do I make sure that people don't call my function on my smart contract? And I only want the keepers network to call that function. And I think like best practice and like in my mind, my mental model for this is if you wanted to pay my utility bill for me and call that function, sure. Like if you want to pay for my electricity, you know, I'm game for you to do that. And it's kind of like that. If you want to call a function on my smart contract and pay the gas fee, like absolutely go for it. I appreciate it. And so when you're creating a function that you're going to automate with keepers, kind of keep that mental model of like, this should be a publicly callable function. Anybody can call it. I'm going to set up a keeper to make sure it's called on a whatever interval or whatever trigger I want it to be set up for. But limiting, like trying to secure it so that only the keepers can call it, like that's not really best practice. Yeah, I think that answers that question. And then there's a couple more questions that just came in. Can you do this for the ERC 1155? You should be able to do very similar things with ERC 1155. That's just a different standard than ERC 721, but like the core idea here is very similar. I know there were some questions about another ERC as well. I don't remember what the number was. I was not familiar with. And yeah, I think that like all of this should apply to any of those. Like this is not NFT ERC 721 specific stuff that we were demonstrating in the fact that it's making a change on chain. It just happens to be for an NFT. All right. Well, I think that's about all the questions. Yeah. And again, if you have questions, you can reach me on Twitter. My DMs are open. I haven't gotten too many spams yet, so hopefully that holds and I can keep them open. My Twitter, I'll post it in the chat here. And yeah, if you have questions, feel free to reach out. I love chatting with people. I love talking about stuff, especially dynamic NFTs. Yeah, I really appreciate it.